Hello everyone, so in this video I'm going to explain in detail the displacement time, velocity time, acceleration time and energy displacement graphs. So we take a look at the first three graphs, which is displacement, velocity and acceleration time graph. So I'm going to use the same animation that I've been using in previous video. And look at here, we have black for the displacement, black arrow for the displacement, hence the black graphs. And then we have the velocity here, the green arrow. So I'm going to use green lines for the velocity time. And for the red arrow here, I'm going to use it for the acceleration time graph. So let's see the movement here. So you can see here, as the displacement increases, the velocity decreases. Here at the same time, the displacement increases, the velocity is 0. That's why when we have the sine graph for the displacement, we have cosine graph for the velocity. And then let's take a look at the displacement here again. As the displacement increases, the acceleration is also increases, but it is in the opposite direction to each other. So hence, when the displacement graph is in a positive sine graph, the acceleration time graph is in the negative sign. Next, we look at the graph energy displacement. So we've learned in previous video that we have here this is the potential energy, this is the kinetic energy, and the total energy summation of these two types of energy is constant, E. Right, so the total energy is constant. Now notice this one. At this point, this amplitude, the energy is all potential energy and the kinetic energy is 0. So I can put it in a simpler form. At amplitude, U is maximum and K is 0 Newton, 0 joule. Alright, and then at X equals to 0, which is at the equilibrium, the energy is all kinetic energy and the potential energy is 0. So I put it like this. At equilibrium, U is 0, K is maximum. Now notice this one. At U equals to K, where is it? It is here. When U equals to K, the object is half of the way to the equilibrium and the theta is 45 degree because they are all 90 degree. So halfway is 45 degree. And then from there, we can calculate what is actually the displacement for this one. So let's see. So we have here, let's say like a pendulum. We have here, and then this is where this is the amplitude. And this, when we swing it like that, this is the equilibrium. So halfway is this much, and that is 45 degree. I am so sorry if my handwriting is not as nice, but we can see here the displacement is this much. This is the X that we want to find. Okay, so what can we do with it? Is that this is actually the amplitude, right? So this is the X, so this is actually sine. So sine 45 degree equals to X over amplitude. So X equals to, now sine 45, we can do the calculation for that. We're going to end up with 1 over sec2 amplitude. So this much is, this displacement is 1 over sec2 of the amplitude, of this whole amplitude. So for the potential energy that is equals to the kinetic energy, the displacement is X equals to 1 over sec2 amplitude. So that's all for this video.